Hi everybody, today's invited speaker is Vetrau. Ivan launched his company Invatechs out of Minsk in Belarus. After working as a hands-on developer for more than a decade, he launched his company, I think about 10 years back. He recently migrated to Warsaw in Poland, and he still has offices in Minsk. He also has offices in Warsaw in Poland and London, UK. His company develops back office products for large and medium-sized organizations. His customers are mostly in Europe. And now he's trying to break into the American market. Now, I know Ivan for more than 10 years, and I am impressed with his, not only his technical skills, but also his ability to run his firm with a globally distributed team. So I thought I can ask him some insightful questions because he has very specific experience, because he's able to support multiple customers, because he maintains multiple versions of the product. So he has pretty unique experiences both as a developer and as an entrepreneur. And he's very responsible. And every time I launch a new product or a new venture, the first person I call is Ivan. And regardless of whichever part of the world he lives, he immediately answers. So here he is. We are going to pick Ivan Vetrau's brain. Ivan, welcome to this class. Hey, okay, Ivan, thanks for accepting this invitation. Welcome to this conversation.
Thank you for having me.
Yeah, you work with multiple customers. You support multiple customers all around the world, and your product runs on the cloud. Okay, so I want to discuss here only things that are usually not covered in textbooks, that are practiced extensively in reality. So maybe begin with infrastructure as code. Since you are creating instances left and right, how do you go about this infrastructure as code?
That's true. You are right. This is important part of the things we're doing in our company, creating different types of infrastructure here and there. Infrastructure as a code definitely and really helps us to make sure we don't have to waste or spend any of our time setting up again and again Linux virtual machines or not servers or anything, right? We just let infrastructure know what we want. By describing it using the sort of programming language, right? And this gives us two important things at the same time. One thing is simplicity, and another thing is repeatability, right? So why it's simple? It's simple because this programming language, it's a sort of a description, right? You just write a description on a quite familiar language, quite familiar to the developer, right? So you don't have to have like a separate Devops or administrator who will be responsible for the setting up Linux, for example, with all its environments, dependencies and stuff like this, and taking care about updates and stuff. All you have to do is to specify in a descriptive manner what exactly you expect from your infrastructure to do, and how do you believe it has to behave. And the rest is done by the automated tools. And there are lots of tools like this available on each and every cloud provider and on almost each and every programming language. And while you are creating the source code for the application, at the same time, you literally create similar source code to your infrastructure. That's it. And second thing is repeatability. If you set up Linux once, right, you know what to do. And next time when you set up Linux, you spend less time on it. But if you create infrastructure as a code script, then you don't have to waste any of your time in dozens of future deployments, right? These two things are super important for any business, right? So maybe it's less interesting for the developer or maybe for DevOps to create infrastructure as a code scripts, but it's much more interesting and efficient for the business to run infrastructure that way.
Yeah, see, I don't think a developer is going to be involved in this process of using, for instance, Terraform is a tool that is used to create infrastructure using code. I don't think a developer is going to be working on it every day. Probably you create a Terraform skeleton once, and then the script also once, and keep running it to create instances with specific storage, memory, where the VM is supposed to be in North America or somewhere else, and so on and so forth. So, but the admin, the sysadmin person is supposed to know. And as an entrepreneur, you need to know how to efficiently use your resources. I guess in both these two situations, it helps a lot.
Yes, yes, for sure. So with infrastructure as a code approach, we just don't need an admin or DevOps personnel. Looks like those positions are obsolete at the moment. Yes, when it's done once, you just keep reusing it, just the way you would reuse pieces of the code. I don't know, for basic stuff like authentication or password storage or something like this, right? Each time you just take it off the shelf, reuse. It gives less errors. It gives more stability and predictability each time you start a new project. Yes, infrastructure as a code, very, very good invention, let's put it like this, of the recent times.
Is it open source, I guess? Is that open source?
It really depends on the infrastructure owners, right? Like AWS or Azure or something like this. So it's on the one hand, it could be open source, but at the same time, it really depends on the infrastructure which is owned by AWS. So it's hard to say if it's a good thing or bad, but well, AWS is a super popular thing to have. Everyone is trying to run their infrastructures there. So, well, it just works. Obviously, sometimes you have to pay for these kind of services. AWS has built-in infrastructure as a code functionality. Lots of third-party providers have different approach, maybe same functionality or maybe something extra. But among all of those options, developer can easily choose the proper one.
Okay.
It's something which will be integrated in his CI/CD in his CI/CD process, and which will give predictable and reliable result.
Okay. And if one were not to use, let's say, this tool Terraform, for instance, they could write a simple Python script to call the APIs that the cloud providers offer you to simply create the instances and other infrastructure, for instance. Isn't that also a possibility?
Yes, it's actually also a possibility. It's a bit more complex compared to off-the-shelf solutions, which already kind of know the instruction, know the way how everything has to be deployed. You still can be in charge of your own infrastructure in the process how it's deployed. And AWS and other providers, they actually have very good SDKs, which allow to literally make all the changes, all the possible tweaks and stuff to the infrastructure you can imagine, you can potentially make through the web interface, for example, but using Python or any other language and using SDK.
Okay.
Well, again, it's a very specific task, and if you really think that existing tools don't really allow you to set up infrastructure properly, you can dive deeper into it and create your own deployment script, which will describe all the little detail you may potentially need in your infrastructure.
Okay, so let me ask you a favor. If possible, could you please email me a copy of, let's say, a Terraform format that you have used? You can remove the information that you think is confidential and then send it to me. I can share it with the students.
Yeah, absolutely, exclusively for your students. And
Thank you. And your product, you sell it to multiple customers. Some customers, buy your product outright. Some customers probably license them. So if you were to maintain multiple versions of APIs for multiple customers, what kind of complexity is involved in this?
Well, it is quite a complex thing. And you are right. So we have to, the nature of our product is it's very, very customizable. And all the time we onboard our new customer, as a business, we promise and deliver an ability to fit into existing business processes, which makes us make lots of changes to our existing APIs, to our existing source code. And the biggest challenge there is make sure that we are not, okay, so the biggest challenge will be avoid making same job twice or 3 times, or for example, when we do the changes to the parts which are responsible for the compliance. And this is quite a common thing to have, because each year the government agencies add some changes to the legislation, and the calculation rules for the payroll usually change each year. We have to make sure that the part of the software which is responsible for the remaining compliance are updated to each and every version of our product, right? So it's a real life task we are facing, well, almost daily. Without proper version control, we won't be able to spend efficient time to introduce those changes to each and every environment we are responsible for. So the right recipe for this is consists of 2 things. First thing, the software architecture, right? So while creating some software, you have to think really, really carefully. Okay, so sometimes it takes even more time to consider proper architecture than implement it.
Yeah.
And it's very true. A proper architect has to sit down and carefully think in which environment his software will be deployed, what kind of tasks the software will deliver, what kind of users they are going to have, how many users they're going to have, and all these factors leading to the certain architecture, right? Well, including the business side of things, right? Like our approach with multiple customers who are demanding multiple versions of our software. And it is architectural solution. The answer for this challenge is architectural. obviously we had to create our code that way to accommodate changes to the code in the future as efficient as possible, right? So I'm not getting into the details, but trust me, the architecture is very important thing. And the second thing is simple and straightforward. It's a version control systems like Git. Well, I believe the most modern and right approach at the moment is Git, and very careful and knowledgeable approach to Git, right? So even Git repository has to have some sort of an architecture, right? There are lots of different types of approaches to Git, and well, it's really hard to say which one is the right one. But if you are decided to use some sort of flow, stick with it, follow its rules, and you won't lose any code. You will be in possession of everything you did and your team did, and you will be happy developer, right? In a different situation.
Yes, yes. So see, the one practical implication of architectural design is, or one practical question to consider is, for instance, here is a piece of logic. Okay, should that logic be in an API, or for convenient reasons, can that logic be, or if it's possible to put that logic in a stored procedure in the database? Okay. So now, can you discuss the advantages of putting this, for example, a Node API? Okay. Or if the choice is to write a Node API or put it in the stored procedures, what are the advantages and disadvantages in these two approaches?
Sure. So as always, these kind of questions has no right answer, first of all, right? And then it has multiple correct answers, and it really depends on if we are considering it from business point of view or technical point of view. So the right answer from the business point of view is, if you have people who are very good at creating stored procedures in a database, then yes, please go ahead and do it. Maybe in the future you will face some issues, some real big troubles in performance or in reliability or something like this. But today you will solve your task and just allow your business to move forward, right? But from the technical point of view, obviously, it's much more complex thing to have, right? So let's consider, I don't know, startup environment, right? Startup is, the software development process in a startup is completely different compared to development process in bigger companies, right? In most cases, bigger companies create their software for years or even dozens of years in the future. Right? So they don't have to, well, they do have to think and carefully consider what they doing, what kind of infrastructure they're using. And at the same time, they already have infrastructure. They have resources to plan the infrastructure for many years in the future. But if you are in a startup, if you are, I don't know, Node.js developer, for example, you have to consider multiple things, like what if you deploy a database which will be capable to run stored procedures, and the demand, like load, right? So the number of users and corresponding number of operations against the database will be high, right? And if this cluster will be actually able to perform or run these many operations as you expect, and how much money will you pay for this in the future? Or maybe, okay, so if you are a rich startup, then okay, go for database, go for expensive infrastructure, and spend some time creating stored procedures. If you don't have that much money, if you are in agile development process, it's much better and much reasonable to consider having all your data processing algorithm in your source code, because database is, so we call it application with a state, right? And state is the data which is stored in database. And obviously data is the most valuable thing you can have, or you can own in your company, in your startup. And if you start putting some extra load on your database, if you start changing procedures, if you start pushing or start making changes to the data structures, then you are in a risk of messing with your data, right? Or making your database not available to your application, or making database not being able to respond in time and lose customers or something like this. At the same time, the very good approach to the backend application itself is creating it stateless, right? Something which doesn't have any state, which doesn't store any data persistently, which makes this application very susceptible to the changes, right? You can introduce any type of change to your production environment if you obviously using proper CI/CD and testing process, like as many times a day as you wish, right? Well, but don't do it on Friday. It's a very bad habit to do changes on Friday.
Right.
But any other day of the week, you can introduce as many changes as you want. And you in this situation, you are not at risk of losing data. You can scale up and scale down your backend much easier than scaling up and down your database.
Well, okay, hold on a second. See, that's a very interesting observation, because as you were talking about scaling, this thought came to my mind, because scaling logic embedded in the database is harder compared to scaling logic that is run on the APIs. For instance, if you want to scale APIs, then you can use containerization, microservices if you want.
Absolutely.
None of that is possible if the logic is sitting in the database, isn't it?
Absolutely, yes. So what you can do with database is to scale it vertically, to add some extra memory, some extra CPUs. But this is logically will be one single point of failure, right? But if you are writing proper stateless application on your backend, you will be always able to scale it horizontally, which means simply adding extra nodes or extra containers to your infrastructure and routing the traffic to that container, again, using very simple tricks available in Nginx, for example, or in AWS infrastructure with load balancer. And that way, well, and it's done real fast, because you don't have to think about moving pieces of data from one server to another. All you have to do is to deploy the source code, and you can scale up and scale down as easy as, I don't know, setting up automatic procedures and metrics when system automatically scale itself up or down when some of those metrics are met.
Yeah, very true, very true. I mean, that is that's a very interesting discussion. Thank you. That's a very interesting answer. You know, the other thing that comes to my mind is the performance monitor. You know, here you have this application running. You know,
right.
You may be hosting multiple clients or multiple customers if you are providing your product as a service. So in the real time, how do you monitor, let's say, memory usage or storage, and then whether sharding is required if the database gets to a bigger size and so on? So the production support and then the real-time monitoring, how do you guys do it?
Well, it's also done automatically. It's also done using infrastructure as a code approach. When you describe what sort of infrastructure in terms of performance you expect to have, let's say, based on your experience, you think that this particular project going to have 100,000 of users per evening, for example, right? And you believe that 3 containers will be capable to handle this type of load. I don't know, based on the algorithm you have in application, based on the size of data, based on the size of traffic coming to and from the customer, making those predictions and describing the result of the prediction into the infrastructure as a code script. You just let the system know, the infrastructure know that it may potentially face this and this kind of issues, not issues, but this kind of demand, right, from the user side. And if it's done correctly, initially it will deploy itself in a minimum configuration, and then following the metrics you also described in the script, it will auto-scale itself up or down depending on the demand which is coming from the users. And in this situation, obviously, you don't have to think much about how many instances of the application are deployed in a cluster. Sometimes you don't even have to think about which geographical location those instances are deployed into. Obviously, if it is described into your infrastructure as a code script. So we just don't really think much about how much memory is used right now, right? All we do is make sure that we automatically, efficiently deliver this memory to our application, memory, CPUs, anything, to our application to perform as it is expected, right? Well, obviously there are some, within container, you have limited amount of memory, right? And you have to really carefully think and design your application to make sure to make sure you are avoiding memory leaks and memory usage. You use memory efficiently, and you actually control the memory use or CPU use. So it's also the important resource to have. But well, it's really done on the during the development process, during the process when developer actually takes decisions, takes actions to deliver one or other functionality. Okay, so one last question for you. This is something we talk about every time we launch a startup venture, and you help us with all this load testing. You know, how would the application perform when there are, let's say, 10,000 users concurrently or 100,000 users concurrently?
So what kind of load testing tools do you guys use in your company?
So, well, okay, it's quite tricky question, actually. I don't really believe there is a industry standard test, load test for modern web application. And reason for this, it's really hard to mock different types of data coming from and to user using standard tools, right? So what we are doing is we create our own scripts, which is also done using Node.js, for example. Node.js is our core programming language or framework. So using Node.js, we create script, which will be deployed on a multiple instances, maybe in an infrastructure nearby, or maybe on the infrastructure on the other country or continent, just to pretend that those scripts are real users and they are calling for APIs, right? With real life data, right? With real life data structures and data sizes. And only that way, we are able to make sure that our test cases match real life people and their behavior. This is something what we are doing in our company.
Okay. Yeah, I mean, that is one thing that is transparent to me. I let you guys do it. So you guys tell me that one, the infrastructure can withstand the load, and two, the database can support the load in case there is a spike in the user activity and so on. So I know that you guys use Node.js extensively.
Correct.
Okay, so today for generic APIs, commercial applications APIs, do you think Node.js is the extensively used framework?
Oh, yes.
Okay, regardless of whether, I'm talking just about JavaScript, okay? For JavaScript in the backend, is Node.js the extensively used framework?
Well, I believe Node.js is the only available stable framework for creating application on the backend. Well, to be honest, I genuinely believe it's an industry standard nowadays. Like, I don't know, PHP used to be 20 years ago or something like this. In 8 cases out of 10, when you start considering creating web application or complex backend application, you start with Node.js. It's very strong and powerful tool. It's very performant. Its performance matches performance of Java applications. It's very strong in terms of support and community. I believe this is the biggest, Node.js has biggest community ever possible in the history of the programming languages or something like this. You literally can find almost all the answers to your questions you have to face daily, right? There are loads of ready to go off the shelf solutions, frameworks like Express. I don't know, any task could be resolved by using simply library from npm. You have to keep in mind that sometimes it's a bad decision to resolve all your needs with npm library, because you never know what's going to happen with this library, right? So, and there are lots of cases when authors of the library taking their software from NPM, from registry. And if your software depends on this library, next time you deploy, you will have an issue, right? But there are thousands and thousands reliable, fast, and very popular libraries available on NPM you can use daily and be safe in terms of features, functionality, security, and all the stuff developers could only dream about 10 years ago. So yes, Node.js it is, Node.js it is. Well, if you are a developer, obviously you can consider some other languages like Golang. If you're creating web services, or maybe sometime for system development as well, or Rust, for example, if you are into developing Linux applications. As you may know, Linux drifting to Rust from C. But if you are rushing to get to the web development and start delivering reliable, good, fast results, Node.js and JavaScript. This is
and one additional advantage is JavaScript is used extensively on the UI side also, on the front end also.
On the front end, not just web, not just browser, but also with mobile application as well.
Right. So training resources may be easier if you go with Node.js because they can work on the front end and the back end and even app development, I guess.
That's correct. Yes, that's correct. And this is actually in our company. This is something when developers start considering their own development or getting more experience, they not start thinking about changing the language. They're thinking about changing the environment they're working with. Coming from a backend, but you can go to the front end, or vice versa. Yeah, it's if you're tired of backend, come on, let's go do some front end, some mobile apps. It's always new fresh thing to have to do and to put into your CV.
Right. And let me ask you one last question. See, you have globally distributed teams. You have some people, you have people in almost all countries in Europe. So when you ask these people to develop your applications and so on, I thought managing these people working in multiple time zones, multiple countries may be hard, and it is hard. So what kind of project management tools do you guys personally use in your company?
Okay, so you know what, I believe the approach is super standard. In our company, we are not inventing anything. We just use Jira and Slack for the communication. That's it. We are not trying, to invent something or use some non-standard tools. Jira is an industry standard. I know there are lots of many new tools or tools who are challenging the Jira position on the market, but nowadays it's a very reliable and well, people know how to use Jira by default in most cases. So this is something you can rely on, right? So you will be able to onboard a new developer easily using Jira. You will be able to run not just software development projects, but also business development project, just the way we are doing it. So yeah, it's a simple and straightforward Jira.
Okay, so I told you that's the last question, but one more last question for you. Okay, Talking to you is always interesting. So, do you guys do any deployment process through Jira? For instance, do you automate it to such an extent that even sometimes deployment happens through Jira? Do you follow that or no?
Well, yes and then no. Jira is not the part of continuous deployment or continuous integration process in our company, but products which are connected and tied with Jira in many cases are parts of the CI/CD process. For example, Bitbucket, right? Bitbucket is also Atlassian product, the company who created Jira, and they have tight connections with each other. So when we the way things running in our company is everything has to be automated very much. And let's say if you just created a piece of code and you want to send it to the repository, you just write a commit in a certain format, and Bitbucket or Git repository will know it, Jira will know it, the CI/CD platform will know it, and as a result, the testing environment or staging environment or production environment will get this information that something has changed and something has to be deployed, right? And it's done using only simple rules of creating a commit message, right? Using your CI/CD or using your CLI or using your GUI Git tool. That's it, right? And Jira is important for the manager, right? For the project manager, who follows the metrics and some data coming from Jira, from the developers to Jira, right? It's important for running projects, for running a development process, especially in a approach like agile. So yeah, it's tied, very tight infrastructure. Everything depends on everything.
Yeah. I mean, it's this is what I call the automation of automation. Software development itself is an automation, and then you make the deployment an automated process. So are you guys following it, or you are following this procedure in some projects?
Well, the nature of our business is we want to be as good for our customers as we can, right? And sometimes our customer actually coming to us with their own process, right? So and we have to comply. We have to pick up the process and reflect it into our own daily routines, for example. But as soon as we are in charge of the things, or of the tech, of the development process, or the deployment process, we are trying to automate as much as possible. Automation solves two things. It gives reliability and simplicity. It's reliable because it's done by computer, done by a robot, right? And well, obviously, you can have some mistakes in describing what has to be automated and how. But when it's done multiple times, all the issues, all the potential problems are wiped out already. And with automation, you just copy and paste your scripts, automation scripts, into a new project, and you get similar results, predictable and reliable. That's it, and it's super simple, right? And this is what actually business needs, right? So it has to be simple, it has to be reliable, and which means cheap, right?
Right.
And this is the most important thing for the business.
Okay. Thanks, Ivan. I really appreciate it. I mean, you are a guy who would always help me anytime I ask for one. I know, what's the time there now for you? 1 o'clock in the midnight?
It's 2 a.m. right now, yes.
Okay, I'm sorry to hold you up. Thanks a lot, Ivan. I appreciate your help, and then go take rest. I will talk to you later. Okay.
Thank you, Ram.